Hello everyone. In our last class, we discussed that refraction through the plane surfaces, and we discussed refractive index also, and relative refractive index and laws of refraction. Okay, in this class, we are going to discuss refraction at curved surfaces. Refraction at curved surfaces. Right, got it? Then, now observe the arrow mark on the board. Now, right, what do you see? See here, before, beaker. Now, when we kept the beaker, before and after. When we are bringing the beaker between our eye and the arrow mark, then it is giving an actual size. When I brought the beaker, empty beaker, between arrow mark and our eye, it is giving diminished one. Right, got it? Then see, diminished or not? See, variation, diminished one. Now, here, okay. Why do you see diminished image? Why do you see diminished image? When the vessel is empty, light from the arrow refracts at the curved interface. When light is coming from the arrow, it refracts at the curved interface, this side. It refracts at the curved interface. Moves through the glass and enter into the air. It is empty one, no? Empty one consists air. Got it? When light is emitted from the arrow, it refracts at this curved surface and enter into the air, which is present in empty beaker. Then it again undergoes refraction on the opposite curved surface of the beaker. Right? Now what happened when it enters, when it refracts the light which is emitted from the arrow mark, and it came to in this curved surface, and it refracts and it enters into air, and again it refracts from this surface and it came out. Right? In this way, light travels through two media and comes out of the vessel and forms a diminished image. Your diminished image. Got it? Right? Diminished and erect image. Got it? Now, what happened if I filled this beaker with water? Right? Okay. Now I am pouring water in this beaker. Right? Then what do you notice? It is arrow mark is showing in reverse direction or not? See, towards my left to right. Right? Then here you consider it left to right. Now right to left. Right? And enlarged size. It is giving enlarged size or not? Got it? Right? In this case, light enters through the curved surface, moves through water, comes out of the glass and forms an inverted image. Now it is inverted or not? Right? It is showing opposite direction. Right? Here assume that the refractive index of glass and water is same. Here assume that refractive index of glass and water is same. Actually, the refractive index of glass and water is not same, but here assume that, okay, then when the vessel is filled with water, there is a curved interface between two different mediums. What are they? What are the two different mediums? Air and water. Here you consider only two mediums. What? Air and water, not glass. Why? Because just I said that assume that water and glass has same refractive index. Got it? Okay. Then once again see the variation. It's showing left to right and right to left. Got it? Right. And enlarged one. Same thing is happening when we kept the lemon in water. It appears enlarged in size. It appears enlarged in size. Okay? Right. Here the surface like this, curved surface, no, right? Here it has a curve. The glass slab has curve. This curve I have drawn here. Okay now, right? This is the curve. Okay. Now this curved surface is drawn here. Got it? Right. Then center of the sphere, this curved surface we have taken from the sphere, no, right? Then the center of this sphere is called center of curvature, isn't it? Now this is center of curvature. I have drawn one normal to the curved surface, then it meets at center of curvature only. Okay, at center of curvature only. And here at the midpoint of this curved surface is called as pole. The midpoint of curved surface is called pole. The line which is passed through the pole and the center of curvature is called as principal axis. What is this? Principal axis. The line which is drawn through the pole and center of curvature. Got it? Right. Here the question. What happened, or how do the refraction takes place when light strikes on curved surface? Question is, how do refraction takes place when a incident ray strikes on curved surface? Right. Like what we discussed in the plane surfaces, same rules in curved surfaces also we have to follow. What we discussed in that case in plane surfaces, when light travel from rarer to denser medium, after refraction the refracted ray comes towards the normal. If light passes from denser medium to rarer medium, the refracted ray move away from the normal, right? Same rules here in the curved surfaces also I have to follow. Now I will show such kind of ray diagrams here. Right. Here in case 1, right, rarer to denser. Here incident ray is traveling from rarer to denser medium. It strikes at a convex surface. What surface? Convex surface. We discussed convex surface means the surface is bulged out. Right. Then here see it. Okay. This is. And see here the normal. This is called principal axis. Why? Because it goes from pole and center of curvature. Right. One rarer to denser. Then here it is a rarer medium. It is a denser medium. It is a denser medium. For example, see here. You feel that water. Water is denser than the air or not? Right? Here you can take a medium as air. Here in this case medium is air. Here medium is water. Okay. So rarer to denser. Okay. Then see here. Incident ray pass parallel to the principal axis. Here the thing is, what is the common rule we discussed in the plane surface? When ray passes through the rarer to denser medium, the light ray bends, the refracted ray bends towards the normal, isn't it? It bends towards the normal, right? Here I am going to draw the normal at a point of incident. Okay, I have drawn a normal at a point of incident. We have to draw the normal at point of incident, no? Right, see. It bends towards normal. It bends towards normal. This is. It bends towards normal. Got it? Right. In a second case, in case 2. Okay. Here, denser to rarer. Denser medium to rarer medium. At a convex surface only. Right? Incident ray pass denser to rarer medium and it strikes on convex surface. Then same surface. See here. Convex surface. Okay. Then here principal axis, pole, center of curvature, and see it. Here this is denser medium now. Here light is traveling denser to rarer medium now. Then see here. Let that these are dotted lines are indicating a water. Okay. Here medium is water. Here medium is what? Water is the medium. Here air is the medium. Okay, Nana? Right? Then this water is act as a denser medium and here it is act as a rarer medium. If ray, incident ray is traveling from denser to rarer, what we have to do when what happened in the case of plane surfaces, when the ray is travel from denser to rarer medium, then after refraction, refracted ray pass away from the normal, right? Then here we have to draw the normal. Now it pass away from the normal, means in this direction. Got it? It passes away from the normal. This is in second case, right? Then in case 3, see here. Here same, rarer to denser medium. Rarer to denser medium. Here incident ray is passed through the rarer to denser medium at a concave surface. Concave surface. What surface? Then now it is striking at a concave surface. Got it? Then see how. Okay. Then see how pole, center of curvature, rarer to denser medium. Here rarer to denser medium on concave surface. Right. Here this side is act as a, here water, here I have taken water, right, here air. Then in this case the water is act as a denser medium, here it is act as a rarer medium. Got it? Then when incident ray is passed rarer to denser, then it is traveling in this direction, right, rarer to denser. Got it? Right. If incident ray is passed rarer to denser medium, after refraction it passes towards the normal. Got it? Then here I am going to draw one normal. Right? Normal. It should bends in which direction? Towards the normal. Towards the normal. Then it bends in this direction. Got it? It bends towards the normal. In case third. In fourth case, here next denser to rarer. Denser to rarer, same at concave surface. At a concave surface. Denser to rarer at concave surface. Right? Then convex one. Okay. Then principal axis, pole, center of curvature. Here it is traveling denser to rarer at a concave surface. For concave surface, then this side. This here I have taken water and here air. Right. Then here water is act as a denser medium. Here air is act as a rarer medium. Here air is act as a rarer medium. Now here ray is traveling from denser medium to rarer medium. Denser medium to rarer medium. Okay. Denser medium to rarer medium. Then what happened to it? It pass away from the normal. Right, got it? Away from the normal. Here I am going to draw the normal at point of incident. Okay, normal at point of incident. See here, it passes away from the normal, then it comes towards the principal axis. This is. Get it? These all the 4 cases. Once again I will repeat. See here. Then here a light ray is passed a rarer to denser medium. It passing rarer to denser by striking a convex surface. Then incident ray is passed rarer to denser. Then after refraction it comes towards the normal and the refractor ray skirts the principal axis. Right? In the second case, the denser to rarer medium, incident ray is passed, light ray is passing through the denser to rarer medium and it strikes at convex surface. right, rarer to denser. In such case, the refracted ray moves away from the normal. And in case 3, then ray passing through the rarer to denser medium by striking a concave surface, then it bends towards the normal because of the refracted ray enters into the denser medium, right. In the fourth case, the ray is traveling from denser to rarer medium by striking a concave surface. It is striking a concave surface and it traveling denser to rarer. No, it moves away from the normal, and it the refracted rays cuts the principal axis at one point. Got it? Right. Here you have to notice that in case 1 and case 4, once you have to notice here, then it cuts the principal axis, right. Okay. In the second, case 3rd and in the case 3rd and case 4th, then they are moving away from the principal axis. Got it? Right. In such case, if you can extend backward, right, and if you extend the backward, then it gives what? Focus and focus. The length between the pole and focus is called as focal length. Got it? This kind of refraction takes place. So what rule we have followed? What we discussed in our previous class. Then when it travels rarer to denser, the refracted ray is passed away towards the normal, and if it travels denser to rarer, it moves away from the normal. Got it? Right. Here one more question. So what happened if the ray is passed through along with the principal axis? Right. Here the question is, what happened to the ray if it is passed along with the principal axis? Got it? Right. Here along principal axis. Right. Then I will say, then surface, curved surface, okay, pole and center of curvature. You can take it is traveling through the rarer to denser. You can take it is as a water, right. Here taken as air. Got it? Then here you can take one more. Here this side you can take as water, then denser, and here it is air, it is rarer. Okay. Here the question is, the incident rays pass along principal axis, either rarer to denser or denser to rarer. Got it? First case, in rarer to denser. And what we discussed in our previous concepts, if it is passed rarer to denser, the refracted ray should pass towards the normal. But here this principal axis is a normal to the curved surface. We discussed in the reflection concept, right? Okay. Then that means it passes along with the principal axis. There is no deviation. In this case also same, it passes along with the principal axis. There is no deviation, right. Then at the same time, if it is passed through the center of curvature, what happened? It passed through the center of curvature. See, same. If it is passed through the center of curvature also, there is no deviation. There is no deviation. Here you can select pole and center of curvature. Whatever it may be, here it is passing rarer to denser, here denser to rarer, no deviation. Why? Because the line which is drawn to the center of curvature from the curved surface, it acts as a normal. Got it? Right? Then this is proved by Snell's law. Okay? Right. Then here, due to these reasons, by following these instructions, light is follows travel when it is travel from denser to rarer or rarer to denser, it passing moving away or towards the normal. Based on this concept, then the lemon in the water is appears in enlarged in size. Right? I will show it. For example, how it is appears? Actually, this is a glass surface. Okay, actual lemon is here, and it appears little bit larger in size. When we will see from here, it appears larger in size or not. Sir, why it is appearing? Then I will show by the ray diagram. Okay, right? This red color marker shows the cylindrical round shape of the glass. Alright, then here lemon, then light emitted from the lemon is fall on it. Right? From the two cases you can take. Okay, this is total water, here it is air. Okay, what happened? It refracts, right? For example, it refracts like this. Then they are moving in different direction. No, what we have to do? We have to extend backward, then they converge at point. After extending backward, they meet at a point, right? Where they are meeting, there the image is formed. Like that, then light rays emitted from here and here, all are acts like this only. Then from that boundaries, you can complete it, you get the size. Then this shows, that means I will use another marker to easy to understand, right? This. Okay, this black color one is shows the size of the image, right? Then image of the lemon. Now imagine that this black marker is shows the then image. This blue marker shows the object. Then this is actual size of the lemon. This is what apparent size. If we will bring the lemon and take the lemon from the water, again it shows the actual size only. Got it? Right. Then here we have a principle to measure the object distance and image distance in the refraction in such cases. Alright, that principle we is taken as either refraction principle, then n2 by v minus n1 by u equal to n2 minus n1 by r. This is the principle. This principle gives us object distance if you know the object distance and the radius of curvature, we can able to find the image distance. Here u is represent object distance, v image distance, and or radius of curvature. N1 and N2 are refractive indexes of given mediums. Refractive indexes of given mediums. This principle, right? While using this principle, again we have to follow the sign convention. What we know the sign conventions. Same sign conventions we will take. Always we have to measure the distances from the pole. Always we have to measure from the pole, right? Then if we measured in the direction of the distances, if we measure in the direction of incident ray, in the direction of for example incident ray is in this direction, we have to take our measurement, and the direction of incident ray in the same direction we have to take positive, or in the opposite we have to take negative, both positive and negative. When we have to take positive, if the incident ray and our measurement in the same direction, we have to take positive. If incident ray and our measurement or in the different direction, we have to take negative values. Got it? Then this is that. Sir, this principle is used for only curved surfaces or plane surfaces also. For plane surfaces also. Then we can, then here N2 by V minus N1 by U equal to N2 by N1. I said we know that for the plane surfaces, radius of curvature at infinity, what r equal to infinity. So here we have to take infinity. Then this value becomes 0, N2 by V minus N1 by U equal to 0. Therefore N2 by V equal to N1 by U. These measurements also we have to measure from the interface of the plane, interface of the mirror. Got it? Right. Then this is the principle. After this, sir, we discussed the laws of refraction. Laws of refraction. These laws of refractions are valid for curved surfaces also or not? That laws of refraction are valid for curved surfaces also or not? Yes, the laws of refraction is valid for curved surfaces also. So we discussed laws of refraction, right? But I said laws of plane surface. No, I said laws of refraction. Got it? Right? Then in our next class, we will discuss about the lenses. Right? Thank you.